So if you've ever wondered how these struct tags in Golang really work under the hood, then you've clicked on the correct video. Because in this video we are going to implement our own custom struct tags in Golang, and honestly they are really straightforward to implement. Now it is important to note that this video is not entirely for beginners. But still, if you are a beginner with the programming language Golang, then you will learn a lot in this video. So let's just quickly define what struct tags really are in Golang. So generally these struct tags in Golang are pretty much a common way to attach metadata to your struct fields. Now this enables developers to use custom annotations that really can be leveraged for purposes or for various purposes such as serialization, validation, or some sort of database mapping. Additionally, this feature allows for declarative programming patterns, where basically additional behavior or logic can be applied within the struct field definitions. Okay, that was a pretty brief explanation of what these struct tags really are. Now let's quickly look at a fundamental concept we need to understand before jumping into the implementation. And the concept is reflection. Now generally reflection means that this concept allows us to examine, introspect and modify behavior at runtime. For instance, reflection can be used to pretty much introspect the types or values of different struct fields, for instance. And this is basically what we need whenever we want to implement these struct tags in Golang, because we can introspect the properties of a variable, we can get the type of a variable, but also we can get these backticks tags in Golang in these struct fields. Now, it is important to note that reflection is a really powerful tool, right? But the thing is, your code can be less performant when you apply reflection. And also it can be really hard to understand and pretty complex to read as well. Therefore, it is really important to note that you only want to apply reflection when only it is necessary. Okay, enough talking, let's get straight into this simple version of just implementing simple struct tags in Golang. Alright, so what we got here is a simple plain old main.go file without any dependencies. And what we want to do now is to first look how to actually define these struct tags, right? How to use them in a struct. So you might know the JSON struct tag, which is known for like serialization, but we are going to implement a custom validate struct tag. Now for that, let's quickly implement a simple struct. Let's call it user. And in here we have, let's say, two fields, right? We have the name, and then maybe we also have the email. Now let's just start with the email. We want to validate this email so that the string is actually an email, right? So we want to have some kind of regex pattern there that just matches up this string with our defined pattern. So with that, we can just define a struct tag in backticks. So struct tags are always defined in these backticks here. And then we are going to make use of the key. So sort of like the tag name we want to use. In this case, we can use validate, right? I mean, this can be anything you want. So for instance, it can be also let me validate, right? Something like this. But let's just keep it simple and clean. Let's use validate. Then we are going to use a colon. So we have some sort of a key value pair where the tag name, the struct tag name is the validate, and then we have the column and then the value, which will be in simple quotes here. Now, and for this value, we are now going to define the validation criteria. So for instance, we can say required, right? So this email is definitely required. We always want that the user defines the email. And then we also just say email, right? So this email is just an identifier for us internally that this field here, this struct field, has to be validated as an email. So that's cool. Let's do the same with name, right? Let's just do backticks again, use validate, and then we use quotes again. And then we say min is equal to 2 and max is equal to 32. And this is another validation we want to implement, right? So the minimum amount of characters is 2 and the maximum is 32. Now, and obviously there are some conventions we can follow or we should follow for just best practices, right? So the first thing is obviously the tag name. So the tag name should be as descriptive as possible and should really intend a clear purpose. So for instance, this validate key here just means for the user that, okay, whatever we define here as a value, this is going to be used as some sort of validation logic. So then another thing, or the two things, are that we want to separate the tag name and values by a colon. So you'll often see that, for instance, with the JSON struct tag, where you have JSON, then the column, and then the quotes here. So this is another convention to use colons and then also quotes around your values. So in this case, around our validation. And then obviously we also want to avoid special characters such as colons or quotes in our tag name key here. Now you might think to yourself, okay, how do we access these values, right? How do we access this required and this email, for instance? So what we can do is pretty much for now just define a simple user, and here we're going to say name, which is maybe my name, and then email, which is going to be abc@abc.de. Now to get these fields, we can use the already discussed reflection, right? Through reflection, we can actually get, for instance, the key here, the tag name, which is validate, but also the values inside of our quotes. So let's just say T, and then we are going to use the native reflect package. And then we are going to say type of, and then user. Now type of basically gets the reflection type of our user struct, right? So it basically returns some sort of struct that contains information about this type of variable, which could be like the name of the variable, the type of the variable, which will be user struct, but also the values of this struct. So let's just quickly test this by just saying print line, and then we say name. And in here, we are going to make use of the name function. And then we also want to get the kind, which is sort of the type of the variable, which will be struct. So if we save this and then run the program, we see that the name is user, which is the struct, and the kind is struct. So the type of variable that is used here. Okay, that's cool, but how can we iterate over these values in our struct? Now to simply iterate over our fields of the struct, we can just use a simple for loop. So we initialize I with 0, then we check if I is less than t.num field. And basically num field, as it says here in the documentation, returns a struct type's field count, right? And here, obviously, this panics whenever the type is not a struct, because obviously it cannot be a struct, right? But we are going to ignore this and just iterate over the num fields. And then we get the field by just calling the field function, which requires an integer parameter. And this just returns the ith field in our struct, right? And then we can get the tag name, like I said before, by just saying field.tag.get. And then we define the key, which is validate. Now what this actually does is that it accesses the key of our struct field, which in this case we said validate. So basically it tries to get this validate struct tag in our user value. So with that in mind, let's just create here a really simple printf statement. And whenever we execute this program, we now get like that the name is user kind of struct, like we've already talked before. Then we have the name, which is of type string. So we can get the type of the struct type or the struct field, right? And then we can also get the tag value. So basically, whenever we use this validate keyword, we obviously want to get the value so that we can kind of match the criteria, right? Or implement the logic for these values. Now that is pretty cool, but let's quickly remove this code here and let's make it a bit more dynamic and create functions for that, and then apply the logic. And by now you should actually understand how these struct tags are working in Golang. In the end, it is just a simple function that gets called whenever basically a user struct, for instance, gets initialized, or whenever we kind of want to pass JSON or get the JSON response of a server. This validation function is called, and in this validation logic we do have reflections and the logic implemented for these values for the struct tag. So without further ado, let's quickly implement a validate function here. And all it takes in is just an interface, which we call val in this case, and it can return an error, right? Because obviously the validation can go wrong. So for instance, if the email is not there, so if it's not defined, like in this use case here, then obviously we want to return an error and notify the developer that this validation actually was not successful. And then what we can do is pretty much make use of the logic we've discussed earlier by just saying reflect.typeOf and then val. Now and then what we can do simply to get the value of this interface is just to make use of the value of function, right? And then define val inside here. And all that does is, like the documentation says, it just returns a new value initialized to the concrete value stored in the interface I, right? So all we get with v is pretty much just the value of our passed in interface here. So let's quickly print this and then return null, because we don't have any error in the end if the validation was successful. And let's just play with some use cases here. So we just say fmt.println and then let's just call validate, and in here we are going to pass in the user. Now if we execute this function or the main.go file, we do get null back, so obviously this is the error which is null in this case. And then we also print the value which contains the values of our fields of the struct. So let's quickly do the same thing with just an invalid user, right? Let's just say invalid user here, and let's remove the @ in our email. All right, let's just get back to our validate function and let's just implement the logic for this validate function. All right, all we're going to do is create this really beautiful for loop. So basically initialize I with 0 and then check I is less than num field and then I++. So we kind of now iterate over the fields of our struct. Then we say field is equal to v.field and then I. So it's basically the same thing like we've used before. So we can also make use here of typeOf instead of valueOf, by the way. So it will result in the same thing if we just print field here, right? So it is in the end the same kind of thing. So we can use in this specific example typeOf, but also valueOf. All right, so we have the field. Let's just get the tag. So getting the tag, we just say v.type, and now we actually need to make use of a valueOf because this returns the type. Then we say field add I. Then we say tag and get and validate. Right? So all we do with this line is basically get the tag of a specific struct field in our struct. And then we just do some simple validation. If the tag is empty, we just continue, right? So if basically the value of the validate key is empty, so if we don't have any values in our quotes, we just skip this iteration. All right, and then we say rules, strings.split, and then comma, right? That is all it takes, basically. Now, obviously, we have to define the tag value here, right? So we have the tag here, so we split the tag by comma, and in the end, we have things like required and email, right? In the end, as a slice. Now, that's pretty cool. Let's just iterate over our rules by using the range loop here. And then we can make use of a switch case here. So we say switch, and then we say case. So if the case is true in this case, so we just say strings.hasPrefix, and here we want to have the rule So I renamed this rules to rule, and the prefix, now let's just implement the min. So in here we say min equals to, right? So this basically means whenever the rule kind of starts with min equals, so in this case it is the name. So if we have here a name which has the validation logic min equals to 2, we just check if this string, so this string here, starts with min and then equals to, right? And if this is the case, we can assume that we want to execute the logic of the minimum check. So with that in mind, we can make use of the logic here for checking the minimum. So we make use of the ATOI function, and then we want to get rid of the prefix, which is in this case min equals to, and obviously I have to define the rule before that, right? So this is now the functionality, how to actually get the min value of this min equals validation logic. And now we do a simple if condition, right? So if basically the length of our field string, so we convert the field to a string. So what field is in this case is just the value, which is, for example, in this scenario, Florian, right? So we check the length of the value here. Now, if this is less than min, we want to return an error, right? I think that is pretty clear and pretty easy to understand. Now we can make use of the errorf function. So let me quickly format this here, right? And this just returns now an error whenever the field value is less than min. And there we go. We now basically have a really simple validation logic for the minimum character validation. So let's quickly do the same thing for the maximum, right? But before we do this, let's quickly have like the field name in here, right? So we declare the field name and then we say vtype field I.name. And instead of using this parameter, we just say field name. I think that's pretty clear. So let's do the same thing with the maximum, which is literally the same thing. So I'm going to quickly skip the explanation part here. All right, and there we have it, a really basic maximum validation logic as well. Let's do the same thing with our required. So let's just remove the logic, and instead of having like the check has prefix, we just check if the rule is equal to required. Now, and if the rule is required, right, then we want to check the value here again. So we just say field string is equal to an empty string, right? So if the length of the string is 0, we can also implement this logic here, but I'm going to keep it as this. Now, and if it is empty, we're just going to return an error again, right? I think that's pretty straightforward. All right, let's quickly do the last rule, which is the email. Now in here, like I've teased it before, we're going to use a simple regex. Now I'm not going to explain this specific regex here, because they are like obviously more complicated regex and all sorts of information online, how to quickly and easily validate an email. But we're going to make use of this. Obviously, we should use a more sophisticated solution for the regex here. Now and then we check basically if the email regex does not match the string field.string, right? We want to return an error again. So if it's not an email, we want to return the error. All right, and this was basically it, all with our validation logic for the struct tags, right? And now let's quickly run our program here. So we say go run main.go, and what we got is nil, which is a successful validation. So we don't get any error. So basically this user here is a valid user. And then we also get a validation error that the email must be a valid email address, because obviously this is not an invalid email address. So what we can do to fix this is just to insert an add here, but let's just maybe remove this field, right? What actually happens here? And because we have the required validation logic and also this value defined in our struct tag value, this email actually gets validated if the email exists or not, right? So if the string of the email exists or not. Now let's get this email back and insert a valid email. And then let's just maybe say that the name is A, right? And obviously this returns an validation error as well, that the name must be at least 2 characters long. And there you have it. You now implemented a really simple struct tag validation logic. Now there are obviously some best practices for these validations or these struct tags, because in the end we do want to inform the user with a really descriptive and informative error message why this validation actually failed, right? Furthermore, we also need to consider if there are like any performance implications whenever the user struct, for instance, really expands to a lot of fields in this struct. And additionally, we do also want to allow like an easy extension functionality for our struct values, right? Or the struct tags values in this case. And right now it's kind of messy, right? We just have this big switch statement and we can refactor this. So let's quickly do this, and this shouldn't take too long, so I'm going to skip most of the parts because in the end it is the same business logic, right? Just in a really more beautiful way. Now let's just get quickly rid of the internal functionality of the for loop here, and then we are going to call a simple function. Now in here we say if an error basically exists in our function we are going to define in a minute. Let's just call it apply rule, and in here we have the rule, field, and field name. And obviously we do need the field name up here, so let's say field name is equal to v.type.field@i.name. And then we check if the error is not equal to nil. Now when the error is not equal to nil in this condition here, we just return the error. That's pretty much it, right? So let's create this apply rule function. So we have apply rule, and in the end it will or it might return an error. And in the parameters we have the rule, which is a string in the end. Then we also have a field name, which will be a string, but then we also have the field itself, which will be of type reflect dot and then value. Now, and in this function, I'm just going to paste in this functionality here, right? So all we do now have is a simple switch case again, which just checks for the prefix, if the rule is required, or if the rule is equal to email, for instance. And then we call and return the correct function for that. So let me quickly implement these functions. Now, like I said before, the logic is pretty much the same, so I'm just going to declare the functions here. Right, and that is pretty much it, right? So what we got is now these 4 functions, which are really basic. And in the end, it always returns an error, right? So for instance, we have here our ATOI function, which just converts the string to an integer, right? And then we have this basic check, which just returns an error if the condition is true, else it will just return nil. And that was basically it. Now, if we run main.go, we get the same behavior, right? And this is pretty cool. So now we've kind of made this logic, this validation logic and parsing logic more extensible. Now, obviously you can go really advanced with this specific use case here. Now, to make this code production ready, obviously we have to add a lot of unit tests, right? Because in the end we do a lot of string manipulation and we really want to have a battle tested version of this specific validation logic. So I might make a video about that as well in the future. Now you can pretty much feel free to enhance this custom Golang struct tags implementation, or maybe implement your own validation logic. And if that all really felt new to you, and if you want a 50-minute crash course on Golang, on the programming language Golang, then I highly recommend watching this video here. Anyway, thank you so much for watching, have a lovely day, and bye bye.